All right. So inheritance is actually one of the most important features of an object-oriented language because it's a really, really powerful mechanism for abstracting a lot of the structure of the world you're trying to model. Okay, so I guess you went through, did you go through the example with the DVDs and that? Did you do that, or did Tim go through a separate example? Sorry? You went through that one? Okay. All right, so you went through all of this in the code, all right. So the point of the example was that initially, without inheritance, you had to have, if you had this database of DVDs and CDs, that you'd effectively have to duplicate a lot of code for the different types of items, whether it was a DVD or CD. Even though there was a lot of stuff, there was a lot of stuff in common, but you have to duplicate it because there are different types. And the idea of the inheritance is that you can take the common parts of those items and merge them into this superclass, and then you only need to have the specialized bits in the subclasses. Right? So all the CD, both the CD and DVD inherit from item all the methods, all the public methods that are declared up there and all the public variables. Things that are declared private up in the superclass are not visible to the children, right? If it's in the parent and they're private, they're private only. They're limited to the parent and can't be seen by the children. Okay, so he showed you this example. So you should actually be fairly familiar with the idea of inheritance, because everybody knows about taxonomies like this, and you know that normally, if you talk about a poodle as a particular kind of dog, it has certain characteristics, but it inherits from its parent all the characteristics that define a dog, and so on. So if it's a mammal, it'll be warm-blooded and have furry skin and all so on to distinguish it from birds and fish and all the other stuff. Normally, we'd stick very strictly to this inheritance hierarchy. When does this sort of taxonomy break down? I mean, this is a good example. Let's say a bird. What are the sort of characteristics you'd give of a bird? Wings, yeah, well. Okay, so that's generally that's true, but there are exceptions, right? So penguins can't fly, emus can't fly, so on. So one of the interesting things about inheritance hierarchies like this is that if you're going to model things, sometimes you have to have exceptions. So you might have a property in here that says bird flies, but if we were to add down to the bottom here chicken, sparrow, and penguin, then the penguin class would have to override the property of its parent and say this thing can't fly. So did you talk about overriding last time? I can't remember if that was... Okay, we'll probably talk about that more. Anyway, so if we were to add to this a different thing, penguin, what we might have to do is do what's called overriding, which says that we'll give it a property that will sort of hide the general characteristic of the parent above, because there's an exception in the child class. Okay, so you went through the syntax of defining classes. So it's fairly simple. All you have to do is add this. When you're declaring your class, you just add this extends item, and that says that this will now inherit from item. Or another way of thinking about it is that this class is an extension of the thing above. It's adding more information to the thing above. Okay, I'm skipping over this, assuming you have covered it. Yes? Okay, we'll keep going. Remember that when you have a constructor for a subclass, you must always have, as the very first statement in the constructor, a call to the constructor of the parent. Right, so in this case, we've got super the title time. So the parameters there have to match exactly the parameters of the constructor in the parent class, right? So that must be there. If you don't put it in, Java will sort of assume that there is a super call, but it won't know what parameters, so it'll be super and just no parameters. And so almost certainly you'll get an error message. Right? So you must remember to put in that super call. Okay. You've done, most of you would have done the tutorial now where you added the extra subclasses in this example, right? Okay. All right, so skipping ahead. Okay. So with variables, here we've got three variables that are all declared to be of type vehicle, and all of these are valid assignments because here we've said that we're assigning to V1 a new vehicle, so it's the right type. V2 is now assigned a new car, and that's also okay because car is of type vehicle. I mean, it's a type car, but it's also type vehicle because it's inheriting the properties of the parent class. And the same with bicycle, that V3 is allowed to contain a bicycle because it also belongs to the vehicle class. Okay, so anything that's a child of that, like any car, any bicycle is also a vehicle. But it's not true the other way around. You can't, if you declare something to be a vehicle like this, V1, you don't know, you can't tell it, say whether it's a car or a bicycle, right? Okay, skip through these. Okay, so I think this is probably where Tim got. Okay, so here's an example where we declare V to be a vehicle again. We declare C to be a car, and we assign it a new car object. And here we've got two assignments. If we assign C to V, that's okay because we're assigning a subclass type to a superclass. Right? V is allowed to contain cars, so assigning C to V is okay. But if we do it the other way around, if we try to assign V to C, Java's going to complain because it doesn't know whether that assignment is going to be correct or not. V could contain a vehicle type, or it could contain a bicycle type. So if we tried to assign it to C, Java will say, I don't know how to handle this, so it's an error. Yep.
We did go through this stuff onwards on Tuesday.
Okay.
Yeah.
So you're saying boring, carry on. Okay. I'm going to keep going anyway because I just want to make sure that people can't understand this. But if you know for sure that up to this point V has been assigned a car, then it's okay to do the assignment. Okay. All right, well, you tell me when to stop. This side? Where, here? That point? Do you see this? Yeah. Okay. All right. The inheritance mechanism makes the collection types especially useful because, let's see if we got, okay. Oh yeah, let's go for here. Java defines a special class called object, which is at the top of every inheritance hierarchy. Right? So everything, all the classes that the Java libraries define, like array list and all the rest of them, all these collection types and hash map, string, all of those, they all are children of the object class. Right? So that's the root of the inheritance tree. That means that the Java libraries can have array lists of object, and they can contain anything. So that's in one way, in a sense, why a lot of the Java libraries work. You don't have to write your own array list code, your own hash map code, or anything like that, because any object that you try to put into any of these things is a child at somewhere. It inherits from object. So as long as because we have array list and array list can contain any objects, then they can contain anything you define. Right? So the guys who wrote the Java libraries only had to write one piece of code for array list, and it covers all objects. Now that includes, you can also put primitive types like integers, floats, doubles, characters, and all the rest of it. You can put those in collections as well. But there's a problem here. The primitive types don't belong to any class hierarchy because they are primitive types. They're if you like, they're the fundamental storage units that Java has. And everything else is defined in terms of them. Right? But if you want to put these into collections, the way that Java handles it is that it has these corresponding classes that these things kind of automatically get mapped into when you want to put them into collections. All right? So this keeps things more or less consistent. That if you have collections or these kinds of classes that can contain other objects, the way to make it consistent so that it can contain primitive types as well is that you turn those primitive types into these objects. So that's why when we talk about these wrapper classes, you've got integer, float, character. So these are classes that, in a sense, represent the primitive values when they go into collections. Now, normally you don't have to do this, but say here's an example where, suppose I have a primitive integer type I, which is we just assigned the value 18. I can create an integer wrapper by doing this new integer stuff, and I can unwrap it by getting int value. Normally, you don't have to do that because of this mechanism called Autoboxing. And what that means is that if you, suppose we declare an array list, and we specify that this is an array list that's going to contain integer types only, then when we do, so you see the mark is of type int, the primitive integer. Now you would think that you shouldn't be able to do markList.add mark because mark is an int, and that's expecting an integer class, an integer object, I mean. But Java automatically wraps the integer primitive, the primitive int, into the integer one, and then it all happens the way you'd expect it to. And the same with going the other way around. Okay, does that all make sense? Okay, let's comment about the stuff in the angle brackets, the integer there. Remember I said that if you, suppose we left that out. Suppose I left out this bit. Oops. Suppose I left this out here. What would I be declaring markList to be exactly? Right? I leave out the angle brackets integer. Then what exactly am I declaring markList to be? Sorry? It's an array list of object, yeah, because if we don't have this narrowing thing in here, so if you don't have the angle bracket stuff, then Java assumes that you want the array list to be able to contain any kind of object at all, right? And by putting that there, you're narrowing the definition and saying, I only want it to contain integer type objects. And usually, that's the better thing to do, because if I left out that integer thing there, then what you end up doing is a lot of casting. You know, the converting right back here. Here we were taking an object that's in a variable v declared vehicle, and by putting this in front of it, we're saying we're narrowing this down to be of type car, not of type vehicle, right? One of the things that this narrowing here does is that because you're being more specific about what the types of all the objects are and what the types of the collections are, you will end up avoiding having to do a lot of typecasting. So that's quite helpful, because otherwise you end up doing that parenthesized type stuff all over the place. Okay, so I'll skip that and move on to the next bit. Oh, hang on, that's the same one, isn't it? Okay, so let's move on to a bit more on inheritance. So now we're going to talk about exactly how the inheritance mechanism works. So let's start out with our DVD and CD database. And let's suppose the code we've written up till now, we've got a generic print routine up in item, and it's supposed to print things out. Well, actually, so if I want to print a CD, the way the inheritance works is, because there's nothing defined in CD, it'll climb up the inheritance hierarchy and find the first occurrence of print going up the tree. And so it'll hit that print item, and it'll call that print. And the same for DVD. So in other words, whichever one we call, DVD or CD, we'll end up getting the same information printed. So whereas we might want individual information, like for a CD, we might want to know the number of tracks and the artist. For a DVD, we might want to know the director, as well as the title and other things. Because we're just using the generic print, we get just the two things that are common to both types of objects, which is the title and the description. Okay? Now, suppose we want to sort of customize the print routine so that we do get the information, the more detailed information for each kind of object. Right, so if we write print methods in both CD and DVD, then these will override the print up the top. In other words, even if we still have a print routine in item, the way that Java works out what method to actually use is it starts at the bottom of the inheritance hierarchy. So if it knows it's dealing with a CD type object, then it looks for the method in this class, and if it can't find it, moves up and so on. But because we've written a one down here, it'll stop there and use that one. Right? So that means it overrides anything higher up in the hierarchy. So remember I was talking about penguins and specializing things. That's what we're talking about here. Okay. So you've got to be a little bit careful with the way that, reasoning about the way the inheritance hierarchy works, because variables and methods can have a static type and a dynamic type. So let's see some examples. Here we've got car C1 is assigned a new class, a new car. So C1 has been declared to be of type car, and the object that it contains is of type car. Right? In the bottom one here, we've got a vehicle, so V1 is declared to be of type vehicle, right, which is the parent type, but we assign to it one of the subtypes of type car. Okay? So we say that V1 has a static type of vehicle, static because that's what we declare it to be, but its dynamic type is car because during the execution of the program, it gets assigned one of the children types, one of the subtypes. Okay? The reason that's important is that if I were to do some of this overriding, like the print routine, then it's important to know whether V1 is containing a vehicle type, like the parent type, or is containing a car type. Yeah, okay, so this example here. So in this one here, let's suppose that we do not have a print up in item, right? But we've declared print in CD and DVD. So now let's say we want to print out all of the objects in our DVD or CD database. If we do that, what's wrong? I mean, it tells you the compile time error, but why would you get a compile time error? Yeah. Yeah. So inheritance only works going bottom up. So if you look at a subtype and its parent contains a print routine, that's fine because it's looking up the inheritance hierarchy. But if you say, if you declare something to be of type item and you try to print it and there's no print method in item, then it won't look down and say, oh, okay, CD, one of my children types has a print routine, I'll use that. It can't do that because it doesn't know what the thing is. Right? So that doesn't work. However, if you do this and have override and allow it to override it, so you declare print to be present in item, but you still have your generic type, and then you also do the overriding in CD and DVD, that will work. Okay, so this is it might seem a bit weird, but it actually does work. Let's see some examples. All right, so we've got an object DVD, or a V1, which is a DVD, and we try to print it. If it's been declared to be, if DVD is a subclass, sorry, what am I looking at? Oh, sorry. V1 is the variable that refers to the DVD object. Right, so this is our actual object, the thing in pink there. And that box is a variable that sort of refers to that object. That object is an instance of, in other words, it's a type DVD. So it'll look for the print method in DVD and finds it, and that works. So did Tim talk about instance of, or have you come across instance of before? Okay, when you create an object of type, say in this case we create an object of type DVD, we say that the object is an instance of the DVD class. Right? And there's actually an instance of keyword that we'll come across and use a little later. All right, so here's another example of the inheritance. We got the variable sorry, variable v1 that refers to the instance DVD, which is type DVD, inherits from item, and if you say print that, it climbs the hierarchy and finds the right print method. If you do that, it'll find the print method in DVD. Okay, so this summary is important. You start with the variable, yep.
So it wouldn't print the item at all?
In this case, no, it'll hit, no, it never will. It'll hit print, it'll take the first one that because it's starting from leaf nodes of the tree up, and it'll use the first one that it comes across.
What if you want to print both?
There's a way of doing it, which we'll look at in a minute, but you've got to do it explicitly. Right? Okay, so you start with the variable that you're accessing, and grab the object that's referring to. You look at the, or this is what Java does, it finds out what class the object belongs to, and then starts searching from that class definition to look for either the method or the variable that you're after. If it's not found, then it starts climbing up the inheritance hierarchy until it hits the first occurrence of the method or variable you're looking for. So the answer to your question is, if you wanted the print method in CD or DVD to also use the print in its parent, then this is the way of doing it. You explicitly say super.print, and that says call, sort of keep looking up the inheritance hierarchy to find the next occurrence of print. Okay? So that's fairly useful if you still want to be able to use the default one that was written higher up. So in this case, it may be useful actually for the DVDs because it does, the parent one does print out the common items of the two types, CD, DVD. So maybe you want to write print in the child class to be, call the parent class to print out the common stuff, and then use my own additional prints to add the details for the particular type of object. So, all right, so actually that's what we do here. Here I've got the definition of CD, and I've got my print method in CD. And the first thing it does is say super.print, which means call my parent's print. So it does print out the title of the item and the description. And then we add the artist and the number of tracks. Right? Yep.
One question. If, say, you're trying to call the print function in a parent that's like 5 classes above, do you have to go to the class on top and ask it to call the other class?
No, because it'll do the same thing. It'll keep sort of saying, find the first occurrence of it. I'm pretty sure. Pretty sure. I actually don't use that very much at all. That's not a very common thing to do. But but I'm pretty sure it'll just keep climbing up the hierarchy. Yep.
If it doesn't find any, it doesn't print anything?
If it doesn't find, if it doesn't find it, you should get an error message. Yep.
Would you be able to do that if the print method in item was private?
No, if it was private, it wouldn't be accessible. It's got to be public. Yeah. Oh, actually, there's an intermediate that we'll come to in a little bit. But if something's declared private, it really means it's inaccessible, right? From outside. Okay. All right. So an example of you've probably come across this already. We've talked about this before, I think, in lectures and probably in tutorials. The toString method. So remember what that does? Who can tell me what toString does? Actually, does it say it there? What does toString do?
Converts an object to a string.
Yeah, well, you'd use it when you want to be able to convert or take an object and represent it as a string. And normally what happens is that when you call print, so if you say object or print object, so system.out.print x, where x is something that you've defined, what Java will do is look to see that if you've defined a method called toString, and if you have, it'll use that to create the string representation of your object and print that out. Right? Now, the reason that this works is that what you're actually doing is overriding toString that was defined in the object class. So remember, the object class is at the top of the inheritance hierarchy. And a lot of the common routines that Java wants to use are declared there. So object has a method called toString. And if you just say print x, then that's you'll end up getting just this generic output of some representation of the object. Usually it's something like the class that it belongs to plus some strange number, a unique identifier. But when you write your own toString method, what you're doing is overriding the system, the object toString method. And so when print tries to do its stuff, it'll pick up yours rather than the object one. Okay, so here's an example where if we want to get, if we just want to allow the normal print to work, we might create some string. There's a Boolean, remember, that says if I own this item, maybe I'll print one thing, and if I don't own it, I'll print something else. So that method, when that gets called, returns a string, and that's what print will end up actually outputting. Okay, I've gone through all that. Okay, so the same thing. So there are a few things where this is true. Suppose you want to find out if two objects are equal. So let's say we have our CD objects, or even just the items. What does it mean for an object to be equal? And there could be a few definitions. Okay, let's take a simple one. I have two strings, ABC, ABC. Are they equal? Would you say they're equal?
I think the definition of not equals means comparing every single binary of that little alphabet and then comparing it with the other one.
Not binary, but yeah, so there's a difference between two objects being, if I have two variables, x and y, if I say x double equals y, the double equals is saying, is the thing in x identical to the thing in y? In other words, do x and y actually refer to the same object? Right? And so the double equals is only true if the things on the left and right hand side are identical. Whereas if I say in the case of strings, I can create one string and put ABC in it, and another string and also put ABC in it. They're not identical strings in the sense that they occupy different parts of memory in the computer, but they happen to contain the same stuff, the same characters A, B, and C. So if I do the dot equals, then what that routine will do is take each string and then go through and character by character compare them. And if they have identical characters, then equals will be true. Right? So there is an equal routine defined for object at the top of the hierarchy. And for strings, it's obvious the way it works. It doesn't necessarily work for a class that you've created, because if it's a class that you've created, so suppose we want to compare CDs. I mean, suppose you're looking for duplicates in your database. You know, you might have created one database item for a CD, and then you've forgotten. You go to the shop years later, say, oh, that's an interesting CD, and buy it, and then realize you've already bought it before. Right? So suppose you want to go through your database and check for duplicates. Then you want to go through and say, is this CD equal to that CD? But what does that mean? It means, do they have the same title? Do they have the same artist? Do they have the same description? Do they have the same track number? So you have to go through and compare each of the fields, and if all the fields are equal, then the CDs are equal, right? The problem is that Java doesn't know what you mean. So we've agreed that that's what CDs, what it means for CDs to be equal. But Java doesn't know that, so you've got to tell it. So you can write your own equals routine to say, what does it mean for one object to be equal to another? And this is exactly like toString. It overrides the system, the equals that's been defined in the object class. So here's an example of, well, okay, so this is an interesting one. So what does the first if statement do? Do you remember what this means? So remember that this is a method that's been defined. So let's suppose we're in student or CD or something like that. Oh, actually, do I have? No, okay, this is better. This is a more specific example. Suppose we have a student class, and we've got the name of the student and the student number and the number of credits, the number of units you've done so far, right? And we only want students to be equal, in other words, the same student, if they have the same name, the same student number, and they've completed the same number of credits. Okay? So this is defined. This is a method defined inside the class student. So what does the first if statement check? What does this mean? Yep. Oh.
If it's the same actual object.
Okay, but so break it down. So I was asking, what does this mean? What does it mean?
When you call it, you'll type in something dot equals, and this will refer to what came before dot.
Yes. So if it's you'll call it like this. And that should have a Boolean result, right? It'll be a return either true or false. So this refers to the object that the method belongs to, and y is the object being passed in. So notice the way that this one is declared. Right? It's not asking, it's not forcing the parameter to be of type student. That declaring obj to be of type object means that you can pass anything at all. Right? So this won't get checked at compile time. You can pass any kind of object at all, a CD or a DVD if you want, and nothing will happen. The compiler won't complain about it. So the first thing you ask is, with the double equals, remember the double equals says, is this object, in other words the x, is it identical? In other words, are x and y really referring to exactly the same object? And if they are, then we return true and we can forget about all the rest because they're identical. Okay? The next bit, remember I was telling you about instance of. Instance of is an operator so when we say obj instance of student, that's a Boolean expression that's going to be true if obj is an instance of the class student, right? So what does that if statement do altogether? Suppose I pass in, suppose y, when I call this thing, suppose y, rather than being of type student, is a CD. What happens when we go through there? What does the exclamation mark mean? Just to make sure you remember that. Not equals not. It's a Boolean not. So if obj instance of student is false, not obj instance of student is true, and vice versa, right? So if y is a CD, is of type CD, how does that, what happens with that if statement? What does it evaluate to? Take it a step at a time. Obj is our CD, right? When we call equals, y, the thing that's stored in the variable y, which is our CD, gets passed in as the parameter obj, right? So now our CD is called obj. As far as this method is concerned, our CD is called obj. So if we ask, is obj an instance of student, is that true or false? Come on, I hope that's obvious. False. So the condition part of the if is true, because we've got the not in front of it, right? It's negated. So it's true, so that means that we do the thing that's inside the if statement, which is the return false. Okay? So the effect of that is to check whether the thing that we're comparing this object with is the same type. If it's not the right type, then we return false. Okay? Now we do it this way. So if I had declared, instead of obj being declared of type object up the top, if I'd said it can only be student, you might think that's sensible. But that would cause an error to occur. If I tried to pass a CD into a student type parameter, I would get an error. In this case, maybe I don't want to get an error. All I want to say is it's not equal, which is true, right? So it's not necessarily an error. I just want to return false. So that's the reason why we allow the parameter is allowed to be of any type at all, and we do this internal checking. Okay? Why do I do this typecasting here? I don't have to, but tell me why I do it. So I'm assigning, I'm taking obj. Okay, sorry. By the time we get to that assignment statement there, we know that obj is a variable that contains or refers to something that is a student, because otherwise it would have failed the test above, right? So now we know that obj contains a student. So why do I do the next bit? Why do I cast obj to a student and assign it to a different variable which is of type student? Yeah. So once I've got a student variable, which is other, then see when I've got other.name, other.id, other.credits, all of these things are field name, ID, credits. They're all fields that belong to objects of type student. All right? Just saying, I'll come back to you. If I hadn't done that, I could still use, I could still use obj everywhere, but everywhere where you see other, I wouldn't just have obj. I would have to have the typecasting. So everywhere I'd have to have student obj, right? And then like something like this. Okay, can you see that? If I do just obj.id, because obj is of type object, like any object, object doesn't contain a field called id, so this wouldn't work. You'd get a compiler error. So you either have to tell Java explicitly to treat obj as a student object, and then you can refer to fields inside it. But that means that you've got to do this everywhere, so it'd be really long-winded. So this is really a convenience. By doing it once and assigning it to a student object, then after that you can just use other, and you don't have to do any typecasting. Okay, is that clear or is it confusing? What was your question going to be?
What was this referring to again? Was it referring to x?
This is referring to x, yeah. Because with this notation, it means that the equals method is contained inside the definition of the class that x belongs to. Right? So that equals method is inside the x class. So here, let's just say that this is part of the definition of student. Right? So here, we're assuming that x would be a student here.
So that statement is basically the same as that?
Well, no, this is calling that. Right? So this method, so when we do x dot equals y, for the first, oh no, so the this refers to x, yeah. Yep.
So in the return where you have name dot equals and then other dot name,
Yep.
that equals method, is it going to call the equals method which is in x, or is it going to go to the standard equals method in the name?
It's whatever type the ID is. So let's suppose the ID is a string. It would be a string equals. If it was some other type of thing, it'd be whatever that is. So it's not. So remember the way it works. It's not this equals. It's the first equals you encounter in the type hierarchy starting with ID. So I mean, once you get this in your mind, it's all clear and simplifies all the code. But sometimes it gets a bit confusing because the same names get reused all over the place, and you have to remember that equals isn't equals. Equals is whatever it is associated with ID. Okay. I think how's our time? I think that's probably it for today. And we'll carry on with more inheritance next week.